What if I told you that on the back of an envelope in my rucksack, I've got the solution to a $1 billion problem? Actually, several $1 billion problems. So, what is it about? Well, it's about something called D-separation, or direct separation. And not just that, but an emergent version of it. One that's a bit hypocritical and a bit more relaxed, yet it'll get the job done. So what are the problems we're trying to solve? Well, the problems really are around the idea of big data being the be-all and end-all. Masses of data is seen as incredibly important, so it requires masses of compute, masses of storage, and that's very expensive. It uses a lot of resources, so we need to reduce our resource usage. Secondly, these models, these frontier models, they have no concept really of consequences or causality. D-separation is a way to climb the ladder of causality. It's meant to be a way to improve on probability and move towards actual causality. So it's a little bit hypocritical to use the power of randomness and probability and approximation to do D-separation. But what we're doing is we're trying to achieve better than what we've previously got. We're trying to do good enough. So approximation is often good enough. It's proved itself really effective in many other mathematical fields. A general rule of thumb, a heuristic, is scale back before scaling up. Less is more. Don't scale up your inefficiencies, just aim to scale your efficiencies. Get rid of the inefficiencies first. Do you remember when we were talking about pruning, when we were talking about regularization and overfitting? Well, D-separation allows us to do that pruning, to get rid of the weak association, the mere correlation, and focus more on what actually is the cause. And so we can get rid of many parameters, many variables. We can sort the wheat from the chaff. And it's lovely because it leverages several branches of mathematics at once: graph theory, probability theory, and information theory. The emergent version of D-separation, in effect, is a transformer, but the attention block becomes a DAG block, a directed acyclic graph block, and then you just repeat DAG block, MLP, DAG block, MLP, and so on. And then the reward engineering is focused on, well, you know, D-separation.